All right. Oops. Work. So, all right. When we did differential equations, solving differential, first of all, what is the definition of a differential equation? Equation with a derivative in it. And the solution to a differential equation? The original equation. Now, up to this point, we have several ways to solve a differential equation. One way would be a slope field. A slope field is an approximate. What's the matter? What? Okay. Like that dog with high pitch. Yeah. All right. So the one way to solve a differential equation is a slope field. If you have a differential equation, you don't know how to solve it, you can plug some points in, do the slopes, and get kind of an approximation of the solution. But it's not very good. Okay, it's not very exact. Then we had Euler's method. Euler's method was a way of doing a little better approximation of at least some of the values, solutions to differential equations. And then we had the easy ones that we already know how to solve, like if I have y prime equals 2x, well, we know the solution to that's y equals x squared plus c, right? I mean, so there are some where we have the input variable, we could just do it a straight antiderivative, and then that works pretty well, okay? And so we could do that. But there are a lot that we didn't know how to solve, right? There were a couple we memorized. Remember that, like Newton's law of cooling and y equals AE to the KT. We just memorized those solutions. There's a whole bunch of others we don't know how to solve. Okay, so today what we're going to do is we're going to learn a class of differential equations that we're going to learn how to solve. It's kind of like in algebra class. You start out doing linear equations, how to solve linear equations. And then you go to quadratic equations, you know, and pretty soon you know how to solve an equation by what it looks like. You identify it as a type of equation. So if I give you a quadratic equation, tell you to solve it, a lot of you will try to factor it. You might think of the quadratic formula. You might complete the square, probably not, but you might. That would be another option, but it's not a fun one. But you know, but once you identify it as a quadratic equation, then you remember, oh yeah, there's a couple of techniques I can use for that type of equation. Well, it's the same thing with differential equations. You get through Calc 3, the next course you usually take is differential equations. And what you learn is how to identify different types of differential equations and then how to solve them. Well, so we've gotten one basic one we know how to solve, where we just do a straight antiderivative. Those are easy. So here's the next kind, separable differential equations. Okay, separable differential equations. Now, we're going to start out by doing one that we earlier had memorized. Y prime equals k times y. Okay? Y prime equals k times y. Now, we said we couldn't do the antiderivative here because it was in terms of y. And this y prime is in terms of x. So if you do the antiderivative, you have to do it in terms of x. Or t, depends. Now, how do we know if this one's using x or t? Well, we don't. We don't. Sometimes the equation is given to you this way, y prime of t, then you know. Right? And other times it's given to you as dy dt, then you know. But in the way it's written now, we don't know if it's x or y. Let's go ahead and use t because, you know, this is one we memorize. We know it's y equals ae to the kt. So let's go ahead and use t on this one. Here's how you work this problem. You rewrite your y prime as dy over dt. That's the secret to the separation of variables. Another way of naming this method is separation of variables. Okay? Separation of variables is what we're doing. The class of differential equations are called separable differential equations. They can be separated. So what we're going to do is, and here's where the separation comes in right here, is we're going to take this dt, we're going to multiply it over to the other side. Okay? Now that gives me dy equals ky dt. Now what I'm trying to do is group my variables together. So I want the y's with the y's and the t's with the t's, and of course k is just a constant, so it could be on either side, doesn't matter. So what I need to do is divide the y over here. Now I'd rather write it as 1 over y because of the reasons of what we're going to do next, instead of divide by y, but I'm going to divide the y over here, and now I've got k times dt over here. So what I just did is separate the variables. You got the dt on one side, the dy on the other side, or the dx, depending on the problem you're doing. Now, this is just begging for what to be done to both sides. You got the dy sitting there, you got the dt sitting there. Oh, it's crying out. It's like that high-pitched sound that only calculus students can hear. An integral. Isn't it? I mean, it's just begging for it. Isn't it? Not really. It must be on a different frequency than we're on right now. Right? It's got that dy sitting there. It just asking for an integral. In other words, that's what we're going to do to both sides. We're going to do the antiderivative of both sides. Now, somebody in the other class asked this question, really good question. They said, well, why couldn't we have done that up here? You said we couldn't do that. We couldn't do the antiderivative of both sides. Well, that's because this y prime is really dy dt. So if we were going to do that antiderivative, we'd be doing it with respect to t, where on this side it's with y, right? And I don't want to get too deep in the weeds here about why you can't, why you could, why you can't. The difference here is now that you've separated the dy and the dt, now when you do the antiderivative of this side, you're doing it with respect to y, and when you do the antiderivative of this side, you're doing it with respect to t. Okay, and because the dy and the dt are there, we can do that. They weren't. Wasn't written that way on this one. Okay, all right. So now. Is it? Are you okay with that? You guys are a lot easier to convince in April about these things, right? Yes, fine. Yeah, we get it. Go on. All right. So now, the integral of 1 over y dy would be what? ln y plus c. Right? We can't forget the plus c. And the absolute value. Right? Remember, that was a rule. Now, it turns out most of the time that absolute value is not that big a deal, okay, on these problems, but we still should look at it just in case here. And then what's the antiderivative of k? Remember, it's with respect to t. kt plus c. Right? Because it's just a constant like 7. Antiderivative of 7 would be 7x or 7t. All right, plus c. Now, what we want, what are we trying to do? We're trying to solve this, right? We're trying to solve it, which means we want to do what? Get y by itself. So I want to come over here and I'm trying to get y by itself. Well, I could subtract the c. Now, if I subtract the c, these c's are not the same c necessarily. They're just some arbitrary constant. So if I call this c1, call this c2, if I subtract c1 from c2, I get c3 or ca or something. I just get another constant. So here's what we're going to do from now on. Here's what we're going to do from now on. Or here's what I'm going to do from now on. I don't care if you do it or not, but I'm usually not going to do the plus c when I do the y side, but I am going to do the output side, but I am going to do the plus c on the other side. If I do the plus c on both sides, which is really what you're doing, and then you subtract the 1 over, you just get another c. So I'm usually just going to do that line this way, and I won't even do this step here with the plus c on both sides, okay? Now we're trying to get y by itself, so I do what next? This is that e notation, so exponential notation. So it's e, so I get y equals, and again, we have the bars here because we want to make sure y was positive, and y is going to be positive, so we don't have to worry about it now. So we get e raised to the kt plus c. Now this doesn't look like what we thought it would. We thought it was going to be a e to the kt. Well, it turns out that this kt plus c in the power, let me write this and see if you believe me. Again, you guys will probably believe me. Probably won't argue too much. But isn't that true? Isn't this true right here? E to the kt times e to the c. Right? When you multiply, you add the powers. Right? So, and what's e to the c? Some other constant. Well, let's call it a this time. Okay? So we multiply by some constant. We'll just call it a, and we'll swing it around front, and we get a e to the kt, and there it is. And so that's how that differential equation came out to have this solution. Now, if there was an initial condition on this, we could stick that in, we could find the a, find the k, and so forth, and we'd have our solution. So that's called solving by separation of variables. Now, some are separable and some are not. Okay? For example, this differential equation right here. is not separable. Now, I'm going to go ahead. You don't have to write this down if you don't want to. But I'm going to show you why it's not. It's because of the plus sign in there. Now, not all plus signs are going to mean it's not separable. But typically, if you're adding both the input and the output, the x and the y, the t and the y, or whatever the variables happen to be, it's not going to be separable. Because look, what's going to happen? Your first step is always to move this dx over here. We never want the dx or the dy to be down in the denominator. You never divide by a dy or something like that, right? You can't have that. So the first step is always going to be to move this dx over to this side. Well, you get dy equals x plus y quantity dx. And no matter how you try, you're not going to be able to get this y over here without also bringing an x or a dx or something with it. I mean, you could try to divide this x plus y over to this side, but now you got an x over on the y side. You could distribute the dx through, but then you got this dx attached to this y, and there's just no way to separate. So this one cannot, this is going to have to be done by some other technique. It's not going to be able to be done with separation of variables. Okay, let's try this one. Y prime equals x squared y. You guys try that one real quick. Try to get, it can be done. This one is separable. Usually if they only involve multiplication or division, then they are going to be able to be separated. Okay, what do we get?
Equals
A times,
e to the 1/3 x cubed.
oops, y equals ae to the 1/3 x cubed. Right? We leave the x squared here, bring the dx over, we divide by the y, 1 over y. So you get ln y, I don't need a plus c on that side. I do. Now, somebody in the other class also asked this question. They said, can you just wait and put the plus c on at the very end? And that's not, and you can't do that. Okay, because notice how the plus c ends up in the exponent, whereas if you packed it on at the end, that would be different. Okay, you have to put the plus c on when you do the antiderivative. So right here we get ln y, then we have this, y equals e raised to that, and we get y equals, and then we have that same thing with the plus c where we can split it apart. Now, could you leave it here? Yes. You could. You could stop right here, put in, if you were given initial condition, you could put it in, and your c value here would be different than that a value, for example. Okay, and that's fine. That's fine. Matter of fact, you could make an argument. I think there is a problem in your homework where sometimes you can't even solve for y. Sometimes you get to here and you're done. Right? And if it did, and on the AP test, if it didn't explicitly say solve for y in terms of x or whatever, you can almost stop. You can stop right here. Now, typically they will say in terms of, if they want you to go ahead and solve for y. And typically, I would try to solve for y. I think that's a good strategy. But really, you've got the solution right here because it's all in terms of just x's and y's, no y primes or anything like that in it. Okay? So I'm not going to get real picky on your final answer. I think on the homework, I'm going to give you ones that pretty easily solve for y, and you should go ahead and do that. Yeah, Zach?
Will it always be A?
No. I mean, we could have called this C. You could have called that big C or whatever. I just did it because that's what we've been doing with AE to the KT. But yeah, some books will call that C or whatever. Okay? So yeah, what constant you use there doesn't matter. Now, and they're not all natural log ones either. Okay? For example, let's look at this one. Okay? Try this one. I'll give you just a minute to think about the separation here and see if you can get that. Now here you can use x. It's okay to use x as the input variable here. You don't know what it is just given this. So x is fine. T, if you're given it in the problem, obviously use what you're given. But in this case, you're not. So if you just want to use x, that's good. Now, obviously, the first step is to properly separate things, right? Properly separate. How will you get these y's over with those y's on the other left side? Anybody got a thought what they're going to do here? Because I had talked about how if you have a plus or minus, a lot of times that made it not separable, but this one is separable. I don't think it's necessary to FOIL it out. Of course, first you write this as dy over dx, right? You're going to move the dx over to this side, right? Because you got to separate it. So if you've got the dx over on this side and you want the y's to get over here, what can you do? Divide the whole quantity, that's right. So here's what it looks like. I'm going to move that dx over to this side. I'm going to move that dx over to this side, and I'm going to divide by that whole quantity. Which essentially, and what would be smart would be, I think, would be to write it 1 minus y to the negative 2 dy equals dx. Now remember, there's nothing over here, but there is a 1. And then you've got the integral of both sides. Right? So you've turned it into that kind of situation. But it is possible that sometimes you need to multiply that dx over there, it ends up being the only thing over there. Okay, well now of course you have to be able to do an antiderivative. What's the antiderivative of 1 minus y all to the negative 2? It's not an ln. Because of that 2 there, it's not an ln. Now if this would have been just 1 minus y on the bottom, then that is a natural log. And you would have to kick out a negative because of the negative y inside. Okay, and you'll get to practice some of that on the homework. But what would be our antiderivative here? What rule do we use? Power rule. We're going to raise that up to a negative 1 and then divide by a negative 1. And have to kick out a negative 1. So the divide by a negative 1 and kick out a negative 1 are going to cancel each other. And we're going to end up with just 1 minus y to the negative 1. And I don't need to put the plus c there yet. I can just put it on the other side. And then on this side we have what? X plus c. Okay, so you do have to be able to do this antiderivative. Now on the test, I'm going to let you use graphing calculators. But I did say on their show all work. Now, how will I know that you just didn't type this into your calculator to get an antiderivative? I won't. So it's not a quiz about antiderivatives, right? So if you need help on the calculator having it do this antiderivative for you for this particular quiz, you can do that. Okay, and it may write it a little differently. Matter of fact, to get the y by itself, and I am going to want you to go farther. when I give you it, I don't want you to stop there. Okay? I would write this as 1 over 1 minus y. Okay? Now, how am I going to get the y by itself here? What would I have to do? Swap, multiply this over here, right? Essentially. Multiply the 1 minus y over here and divide by this whole quantity. So it does kind of amount to swapping those. It's kind of what happens. And then we can subtract 1. You'd have negative y, and then multiply everything by a negative. And so this would turn negative, this would turn positive, so it'd end up looking like 1 minus 1 over x plus c or something like this. Oops. You know, and there'd be a variety of answers that would be okay, you know, negative that fraction plus 1 or whatever, or get a common denominator. That's what your calculator would do. If you told it to solve this one right here, if you put that in your calculator, told it to solve for y, it'd probably look a little different than what we have right there. And then don't forget, if we have an initial condition, we have to then plug that in. Okay? So that is separation of variables. So let's take a look at your packet, your sample 4 packet. And I think it was problem 25. Didn't we skip this one? Or did you? A lot of people in the air class had an answer. I think they just guessed.
Well, like we know the.
Use logic.
And that's good.
Use logic.
He used logic and filled the rest of it in.
Y prime is equal to 2yx, so y is equal to.
Hang on here a minute. So y prime is equal to 2y over x.
And then we know the equations of all of those on the left, like a, b, c, d, e.
Right.
And I went with parabola first, like I just wanted to.
Okay.
And then, so that's y equals x squared.
That's
And I did the
one
derivative.
example of a parabola.
Yeah.
Okay.
And then I did the derivative, and it was y prime equals 2x.
Okay.
And then that matched.
And so if you put y prime in here, which would be 2x, kind of verify that t-chart thing we did, and you put 2y in here, which would be 2x squared over x. X is canceled, you get 2x equals 2x, seems to fit. Okay? Yeah. And we've said that often on these multiple choice questions. Oftentimes, if you don't know exactly what to do, you can get the answer just by kind of thinking through or looking at the choices and so forth. And that's perfectly fine. I have no problem with that. But now that we've had the discussion we just had, doesn't this look like a separation of variables? Right? Now, without going too far into it here, because I want to spend a little time on the free response question, you get dy over dx equals 2y over x. So you bring the dx over to the right. So you have 1 over x and the dx. I'm going to divide the 2y over to this side. I could just divide the y and leave the 2, but I'm going to probably would have made it easier actually if I would have done that, but I'll go ahead and do this. Okay, so it ends up looking like that if I divide the 2y over and I multiply the dx over there and then do the integral of each side. Now what happens is you get a couple of natural log problems. Like here I could pull out that 1/2, so we would have 1/2 ln y equals, and over here we get ln x plus c. Right? That's the stuff we just learned. Now I'm gonna leave it for you to finish the rest if you want to, but here you'd have e raised to all this equals, well, you multiply the 2 over there, and then you'd have e raised to all that, and then separate out that a like we talked about. And then what happens is you end up with an e to the ln x. Right? Well, what's e to the ln x? Just x, right? Well, actually, because you multiply the 2 over there, you bring the 2 up top, you get x squared, so you really get e to the ln x squared. Well, what's e to the ln x squared? X squared. So you end up with y equals x squared, which is a parabola, and that's how you, one way you could solve it. But what you did is not all bad either, especially for a multiple choice question. Okay? All right. So with the time we have left, I want to go to the free response question, number 4. Oops. Number 4 was not assigned. Okay, which one is this? Number 2. There it is right here. Okay, this is a no calculator one. Now, this is a very similar to a problem we did early in the semester. It's called Torricelli's Law, water draining out of a tank. Said that the rate that the tank decreases is proportional to the square root of its depth. And they give you this right here. Almost always, one of the one of the 6 free response questions is a differential equation problem. Very similar to one like this. Look at part A, and this is what I want you to spend a few minutes doing. Find the solution of this differential equation. Well, you look at this, there's h. H is like your y, equals negative k times square root of h. That's not one we can do a simple antiderivative, but it is a separation of variables. So go ahead and do part A, solve this differential equation. Okay, now the first step is getting it separated right. So I'm going to put that up here. If you don't want to look, don't look. But I'm going to put up what I have when I separated it. Okay? That's what I got when I separated. Because you square root you divide by the h to the 1/2. To get that h over the other side, you divide by h to the 1/2. Well, that's going to be 1 over h to the 1/2, which would be h to the negative 1/2. Okay, the negative k I just left over there. And the k I could have divided, but there's no reason to. It's a constant, it could be on either side. And I moved the dt over there. So that's, and this is not a natural log now. This is a power rule, right? Okay, so do your antiderivative. Okay, so we raise that up 1, so that would go to 1/2, divide by 1/2, which would be multiplied by a 2. And the other side is negative kt. So we got 2h to the 1/2 equals negative kt plus c. You can't forget the plus c. That's the time that goes on. Then I divide it by 2. Now, Somebody in the other class asked me at this point, could you divide this whole side by 2 here? And I said, that's fine. What I did was I divided this by 2 by putting the negative 1/2 in front, and then left the plus c, because if you divide by 2 on plus c, on a c, it's still a c. The difference there is my c is going to come out different than what their c would be, but it's still the same equation, we just look a little different. Okay, mine will come out plus 4, those will come out plus 8, and then all over 2, but it's the same thing. And then I squared both sides, because you got h to the 1/2, or square root of h, so I squared both sides, whoops. I squared the whole thing.
Is that one
Are
in
you
terms of
allowed
K,
to
though?
do that?
There you go.
Can you
Now,
swear?
We're, I don't, well, technically that's what you're doing, you're squaring both sides, and so I guess you could do that, you could put the whole thing with a big square on it, okay? Now, but you're not done, that's right. You're not done, why? Well, it is in terms of k in the sense it's got k in it. It's still going to have a t, and what they're telling when they say in terms of k, that means it's got k's in it. Okay, it's got k's in it. It's h equals, and it's got k's in it. It's going to have t in it too. Okay, but it shouldn't have the c. Why? What can we do to get the c? Initial condition. At the beginning, the tank is filled to 16 feet. So we put a 0 in for t. Now the way I wrote it, it's pretty easy. Put a 0 in for t, makes that whole term 0 plus c. So we get c squared equals 16. So c would equal 4. So c would equal 4. Okay? So I would replace that with a 4. Like I said, if you would have taken the whole side and divided by 2 and then squared it all, you'd have had a plus 8 and then all divided by 2. But it would, again, it's the same equation. That would have been fine. Okay, so that answers that part. And then in part B, they give you another condition. Well, that's going to help you then find K. So you'll plug that number in, you'll find K, and then they ask you another question. So you don't have to do that necessarily right now. I mean, there will come a time here over the next week that we'll finish sample 4 and be moving on. So you'll have to finish that problem. Okay? All right, so tomorrow we have some things to catch up on because of this evacuation route. I didn't give you a chance to ask any other questions on sample 4. You've got some of those. We'll get to those at a later time. I am going to pass out this worksheet. Basically, though, your assignment is this 7-4 line on the sheet. It's about 7 or 8 of these differential equation problems. Just separating the variables, doing the antiderivative of each side, that kind of thing. They're all separable. They're all ones you should be able to do. Some of them give you an initial condition, so you on those you go ahead and you find the C value. Now tomorrow, so that's your main assignment. Tomorrow, one of the things we'll do is give you some time to work on some volume problems. That's what this sheet is here. I would save those for tomorrow in class. So this worksheet, most of it you're going to save for tomorrow in class. But what I would like you to do is work on 5 and 6 a little bit for tomorrow. Those are the harder of the problems on the page. They're not necessarily, well, you may have to do something similar, maybe on one problem on the quiz, you may have to do something like this. What I don't want you to do is spend all of your review time tomorrow trying to work on 5 and 6. Because that's going to take away from the review time you should be spending on most of what's on the quiz. So before you get here tomorrow, you should have worked through 5 and 6, and then I can help you answer some of the concerns you have on 5 and 6. I'm not going to take time to work through 5 and 6 together with everybody. But I will answer some questions if you get stuck at a certain point and so forth, so on. Okay, so basically your assignment is the 7-4 on the assignment sheet and these last 2 problems on this worksheet. Okay, that leaves you about 15 minutes here to get started on it until they call us for the evacuation.
Hey,